In today's notes video, we are going to be talking about circumscribed and inscribed polygons. A circumscribed polygon is a polygon that is circumscribed about a circle if each of its sides is tangent to the circle. So when it says circumscribed, that means that we are putting a polygon around a circle. And it's tangent in each place because that's where it touches our circle. Whenever we work with finding the perimeter of a circumscribed polygon, we have to get a little creative and work it sort of kind of like a puzzle piece. We have to remember that tangents are equal when they come from a single point and touch the circle. But each of these tangents is going to be a little different. So while these two tangents are congruent, these two parts of my tangent are going to be congruent. And these two parts of my tangent are congruent, but each piece may not be the same. We're going to work through these. Normally you'll be given one smaller side as well as two longer sides, and we have to find out the entire perimeter by piecing together and finding out what this amount is. Because if this is 7, we can't assume that the next part is 7 just because it's part of a different tangent relationship. As I work through these, first of all, I know that from this point to the edge of my triangle is 7. I can keep going with that 7 and say that from the edge of my triangle to where it touches the circle here is 7 units. Since this entire line is 20 units, that tells me that from where it touches the circle to the other edge of my triangle, we have 13. Since this tangent is congruent to this tangent, we can say that from the edge of the triangle to where it touches the circle is 13. Finally, we get to the part where we really need to know some information. From this part where it touches the circle to the edge of my triangle, we know that it is going to be 9 units because the whole side is 22, but this part takes up 13. And that tells us that from the edge of our triangle to where the circle touches there, we have 9 units. So each corner of the triangle matches up. It's sort of kind of like if you tried to have 3 people create a triangle with their feet and stand in a circle. Each person's sets of feet would be a little bit different sized, but we can add them all up to get our perimeter. From there, you have 2 options. You can either add up all these little tiny pieces that we found, or we can add up how long each side is total. So this entire side is 16, plus this entire side was 20, plus this entire side was 22. So when I add all of those numbers up, I get 58 is my perimeter. As we move on to the next part of our notes, we're going to talk about inscribed polygons. A polygon is inscribed about a circle if each of its vertices touch the circumference to the circle. What that means is that every corner of my shape must touch the circle that is around the outside. One important piece of information to know is that opposite angles of an inscribed quadrilateral are supplementary. So angle A and C will add up to 180 degrees. And angles D and B are going to add up to 180 degrees. When we look here, it says if A equals 110 and D equals 70, what are the measures of B and D? So to solve, we have to remember that A plus C equals 180 to start off with. So we can find C And this should say B and C, not B and D. So if A plus C equals 180, we can plug in 110 for A. And then we just subtract 110 from each side. So we know that C must be 70 degrees. Then, since B plus D equals 180, we can follow the same steps. B plus D equals 180. So we could also rewrite that as B plus 70 equals 180. To solve for B, I'm going to subtract 70 from each side. So B equals 110 degrees. Now, as we look at this, the thing that we have down here at the bottom says that if a parallelogram is inscribed in a circle, then it must be a rectangle. This is not a parallelogram because the sides are different lengths and our angles don't match up. This is just a general quadrilateral. If it were to say that it is a parallelogram, then we would assume that it is a right angle, because the only way that it can have two sets of parallel sides and be in our triangle is if it's a rectangle. So this is just a special thing to take note of. If a parallelogram is inscribed in a circle, then it must be a rectangle. We're going to go ahead and flip on to the next page of our notes, and we're going to do some practice with each of these topics that we've learned about. We're also going to do a few applications of what we've learned. So for problem number 1, it says parallelogram LAKE is inscribed in circle S. If the radius of circle S is 5, angle LAK is 90, and AL equals 8 centimeters and AK equals 4 centimeters, find the area of the shaded region. Wow, that is a lot of information. So the first thing we know is that the radius, so from the center all the way to the side of our circle, is 5 centimeters. Then we were told that angle LAK is 90 degrees. And if this angle is 90 degrees, that means that all of our angles are 90 degrees. So this is a rectangle, and it looks like a rectangle. Next, it tells us that AL is 8 centimeters. So this line segment right here is 8, and AK is 4 centimeters. And it wants us to find the area of the shaded region. Anytime that it brings up finding the area of a shaded region, we're going to have to first of all find the area of the entire shape, and then we have to take away the area that we don't want. The entire shape here is a circle. So we need to know, first of all, what is the area of a circle? And the formula for the area of a circle is pi r squared. The second thing that we need to know is the area of a rectangle. And the area of a rectangle is length times width. To start off, we need to find how much area is in this entire circle. To find the area of my circle, I need pi and I need my radius. That's what r stands for. So to find the area of a circle, we are going to do pi times our radius, which is 5, squared. And when I type that into my calculator, I will get pi times 5 squared, which is 78.5. Now, we don't want the area of the entire circle. We just want the area of the shaded region. So that means we need to take away the area that is being taken up by that rectangle. So I'm going to do my area of a rectangle, which is length times width. Length times width, my length is 8, and my width is 4, so that would be 32. So to find the area of the shaded region, I have to take my whole area of the entire shape and subtract the part that I don't want, which in this case is the rectangle. So I would do 78.5 minus 32. 78.5 minus 32 is going to leave me with 46.5. And because this is in centimeters, we would do centimeters squared. We are going to do something similar with problem number 2. With problem number 2, PANT is a square. The diameter of circle S is 8 feet, and it asks what is the area of the shaded region. So the diameter of this circle from one side to the other is 8. Now we see that we have a square and we have a circle involved. So once again, we know that the area of a circle is equal to pi r squared. And we can say the area of a square is equal to length times width, or you could think about it as side times side. When it tells us the diameter is how long it is from one side to the other. So that means the dimensions of our square are 8 by 8. But we also need to know our radius, so we're going to be able to figure out the area of a circle. So if the whole thing is 8, that means our radius is 4. Now this problem is slightly different from the one we did before. Our last problem, the whole shape was a circle and we were taking a rectangle out. Whereas in problem number 2, my entire shape is a square and I'm pulling away my circle. So we're going to find the area of each piece and then do the math to find out what the area of my shaded region is. First thing I'm going to do is find the area of my square, because the entire shape is a square. To find the area of a square, I'm doing length times width, which is 8 times 8, or we could say 64. And since that's in feet, we could say feet squared. Then, to find my area of a circle, I would do pi times 4 squared, because since my diameter is 8, my radius would be 4. And when I type that into my calculator, I'm going to get pi times 4 squared equals 50.3 feet squared. Once we have the area of our square and our area of a circle, we're going to subtract the area of our circle because we don't want the part that's in the circle. We just want the edges. So I would do 64 minus 50.3 equals 13.7, and we would say feet squared since we're talking about area. So anytime we do a problem where we're trying to find the area of the shaded region, we're going to have to find the area of both shapes involved in the figure, as well as subtract them to find what the area of the shaded piece is. We have 2 more problems that we're going to touch base on that are a little different from these area problems that we did up at the top. I would recommend you guys going back and looking at these. These are very similar to problems that you may see on your test. As we come here to example number 3, it is asking us to find the perimeter of the quadrilateral. Now, as we go around here, all of these lines are just a bunch of tangents. So I'm going to make congruence marks so I know what piece will go with what. This line is congruent to that line. This part of my tangent is congruent to this part of my tangent. This tangent is congruent to that part of the tangent. And this part of my tangent is congruent to that part of my tangent. Remember, think about it as if you were to put your feet together and try and make a figure with somebody else's feet. Your 2 feet are the same, but every corner is different. We're going to go around and label each piece. That way we're going to be able to add everything up to find our value. First of all, if this part of my tangent is 1 inch, then this part of my tangent is going to be 1 inch. If this part of my tangent is 3, this part of my tangent will be 3. If this part of my tangent is 2, then this part of my tangent is also 2. If this part of my tangent is 5, then this part of my tangent is 5. We have 2 options of how we can find the perimeter. We can either add up each individual little piece, or we can add up the entire sides. Since everything is broken down into little pieces, I'm just going to add every little piece up together. So 1 plus 1 plus 3 plus 3 plus 2 plus 2 plus 5 plus 5. When I add all of those numbers together, I end up with 22 inches, and we can just put the 2 little commas, or 2 little parentheses. I guess it's 2 little apostrophes up by it. So we just went around in our pattern to find each missing number and added everything together. For our final example, we're going to look at number 4. It says, what are the measures of the missing angles if angle 4 is 60 degrees and arc MEN is 220 degrees? So arc MEN is 220 degrees. This problem is a little bit of a challenge because it gives us an arc instead of an angle over here. But we're still going to be just fine. Anytime it gives you an arc, you're probably going to need to solve for an angle with that. As we look here, the arc formed by that angle, or the angle formed by that arc, is right here at angle NAM. In order for us to go from arc to angle, we have to divide by 2, since this is an inscribed angle that's all the way on the other side. So angle 1 would be 110 degrees, since we divide 220 by 2. From there, we know that angle 1 plus angle 3 is going to equal 180 degrees, because our opposite angles add up to 180. Since angle 1 is 110, to find our angle 3, we would just subtract 110 from each side of our equation. So angle 3 is equal to 70 degrees. Finally, we also know that angle 2 plus angle 4 equals 180. Since we know that angle 4 is 60, we can plug that in for our angle 4 and subtract 60 from each side. So angle 2 is going to equal 120 degrees. That is all that you guys are going to need to know about circumscribed and inscribed polygons. Please let me know if you guys have any questions about these examples, and use your notes to help you on the daily quiz.